So our next project is to get acquainted with the formalism of sentential logic and to learn our first method for proving the validity of an argument. And this is the truth table method. So that'll be our first method of proof. We'll begin by learning how to represent declarative sentences using variables. We'll learn about the role of the logical operators in establishing the form or the structure of arguments. We'll learn how to construct well-formed formulas of sentential logic. And then from there, we'll build up the machinery for proving validity using the truth tables. So let's begin with, we're going to begin with the declarative sentences. So at this point, as you all know, a declarative sentence makes a claim about the way things are. So we can contrast declarative sentences with questions or instructions or exclamations or involuntary noises and so on. So usually we'll say that a declarative sentence is either true or false, and we'll talk about some exceptions in the text. And by contrast, a question or a command is neither true nor false. So declarative sentences then will be the building blocks of reasoning and argumentation. But then the formal characteristics of an argument or a piece of reasoning are going to be the way that those building blocks are joined together. So as we follow the movement of an argument from one step to another, we'll evaluate the merits of each step, each connection between the blocks. And the steps then in a good argument are going to accord with the rules of logical inference, and we'll talk about those too. And a bad argument violates the rules of inference. So now what about the logical operator? So as we've seen, in English, we use phrases like and or, and not, and therefore, if then, hence, but, if and only if, and so on, to connect the components of sentences or to mark the transition from one idea to the next, to join the blocks together. So in logic, we'll define logical operators that end up looking similar to those of ordinary English, connecting words like these, but the function is going to be to connect declarative sentences to form more complex, compound sentences. So the logical operators then are what give arguments their form, and they would allow us to make inferences. And these operators then are responsible for the formal structure of the argument. What we'll do is we'll introduce symbols for all the relevant logical operators, and we'll begin, for example, with something like the AND operator. And as we'll see, in the case of the logical operator, we'll use a dot instead of the English word and that'll be our symbol. And the operator which we'll define, the dot operator, the conjunction operator, is worth distinguishing carefully from the English word and, but there are enough basic similarities between the properties of the logical operator, the dot, and the semantics of the English word and that we can safely ignore the differences for the purpose of our discussion here. But these differences are important and they're discussed in the text, so please look at that. Then our first exposure to the truth tables will come as we introduce the definitions for each of the operators. So you'll learn how to construct a truth table as we introduce, each of the operators. Once we've studied the logical operators, then the next order of business is to understand how we can legitimately break complex sentences up and join sentences together. And we'll learn what kind of formulas count as well-formed formulas. We'll examine the notion of scope. We'll learn how to use the syntactical rules of our formalism to help us figure out the right order for evaluating operators, etc. And then from there, we'll learn how to prove the validity of an argument using truth tables. Okay, so along the way, we'll talk about disjunctive and conjunctive normal forms, and we'll see how the logical operators relate to, for example, circuits and logic gates in engineering. So at this point in the course, it's especially important that you practice your skills by doing the exercises in the text and on Blackboard. And where I've indicated, it's going to be really important for you to actually memorize some of this stuff. So you'll need to be able to know the truth table definitions for the most important logical operators. And you'll need to master the technique of generating proofs using the truth table. So that's going to be a necessary step before you can move on. Okay, so let's get started.